So this short video is going to help you understand factors and prime numbers. So I can write out the number 1 as 1 times 1. I might bring 2 out as 2 times 1. So these numbers go into, 1 goes into 1, 2 goes into 2, and 1 goes into 2. So there are factors of, so 2 and 1 are the factors of 2. 1 is the factor of 1. We don't say the other one as well, so we're just repeating the same number. So 1 has 1 factor, 2 has 2 factors. 3 has 2 factors, 3 and 1. 4 is the first one that's different, because 4 can be made by 4 and 1, or we can make it by 2 times 2. So the factors of 4, I put them in order, are 1, 2 and 4. Factors of 5, 5 times 1. I'll just write the factors here, 1 and 2 and 3. So 1 and 3, I'll just put them in the size order. So we've got 1 and 5 here. On to 6, we've got 6 times 1 or 2 times 3. So that will lead to 4 factors, 1, 2, 3 and 6. 7, just has 7 times 1. So that's 1 and 7 other factors. I'll just circle the factors so you can see clearly where they are. The list of factors. Into 8, so we've got 8 times 1, but we've also got 2 times 4. We've got 1, 2, 4 and 8. 9, we've got 9 times 1, so that's just 1 and 9. So I'll circle these. And finally with 10, we've got 1 times 10, or 2 times 5, so that gives me 1, 2, 5 and 10. So hopefully you can see that factors come in pairs, and when we multiply two numbers together, we get another number, and the two numbers in the multiplication are automatic factors. If some numbers though only have factors of 1 and themselves, so the numbers that have factors of 1 and themselves are 2, 3, 1 and 7. Right? And they are special numbers. They are our prime numbers, because the only factors of prime numbers, let's call the number n, the factors of a prime number n are 1 and n. So the factor of 7, for example, are 1 and 7. Factors of 5 are 1 and 5. But the prime numbers then are 2, 3, 5 and 7 in the list from 1 to 10. Now 1 is a bit of an odd one because it only has 1 factor, so it's a bit of a special number. There is a bit of an argument amongst mathematicians as to whether it is a prime number or not. But you're never going to be asked whether it's going to be a prime number in your exam, so don't worry about that. But the numbers 2, 3, 5 and 7 are all prime because they only have factors of 1 on themselves. The factors of non-prime numbers have more than 2 factors. So in the case of 4, we have 3 factors. In the case of 6, 8 and 10, we have 4 factors. Larger numbers can have lots more factors. So if I asked you the question, is 29 prime? Then the answer to that question is yes, if you can't find 2 numbers that multiply to give you 29, other than obviously 1 and 29 themselves. So if you can't think of any number, if you think 29 is not in the times tables, then your answer would be yes, it is prime. And in this particular case, that would be right, because we can only make 29 by doing 1 times 29. There's no other way we can do it. However, if I say to you, is 27 prime? Then the answer to that would be no, because we can make 27 from 3 times 9, as well as 1 times 27. If I said to you, what are the factors of 27? So the factors of 27, then you would hopefully say it's 1. Don't have to be in order to start with 1 and 27, 3 and 9, and if we want the order, 1, 3, 9 and 27. So to recap then, prime numbers only have factors 1 and themselves. Also, you might notice then, apart from 2, every other even number will not be prime. So for example, 16, 4 times 4, 12, 2 times 6, and so on. So it's only odd numbers that might be prime once we're past the number 2. So that's a lesson on factors and prime numbers.